Welcome to the SI Academy of class 9th, second chapter is matter around us pure. You want the previous videos of this chapter means okay, check our playlist. You got all the videos of this chapter. Okay, our next topic is colloidal solution. In a previous video discussed that the what is a suspension, what is the meaning of suspension. Also we discussed that properties of a solution, properties of a suspensions. Okay, these are two important topics about suspension and their property we discussed in the previous video. You want these topics means you can search in our playlist, you will got it. Okay, next okay, the mixture obtained by a group D in activity 2.2 is called as a colloidal or a colloidal solution. Okay, in a chapter in a earlier chapter of this matter is around a pure, we done some activity 2.2. so in that the solution is obtained in D, that is called as which type of solution? That is a colloidal solution. The particles of colloid are uniformly spread throughout the solution. Okay, the particles of colloids are what? Uniformly spread out through the solution due to the relative smaller size of the particles as compared to that of suspension. The mixture appears to be homogeneous. Okay, the size of the particles of colloid is what? Very small, and it look like what? A homogeneous mixture. Again, they are uniformly spread throughout the solution, so they are look like homogeneous, but they are not a homogeneous solution. These are what? A heterogeneous mixtures, remember that. But actually colloid solution is a heterogeneous mixture. Okay, for example of what? Milk. So colloidal solution are look like a homogeneous mixture because the particles are what? Spread uniformly throughout the solution, and the size of the particles are very small. But the size of the particles are small, but we cannot say that this is a homogeneous mixture. So this is what? It is a heterogeneous mixture. Remember that colloid suspension both are what? Heterogeneous mixture only. Solution is a homogeneous mixture. Because of the small size of colloidal particles, we cannot see them without our naked eyes. Okay, so with our naked eyes we cannot see the particles of a colloidal because the size of the particles is what? Very small, so we cannot see with our naked eyes. But these particles can easily scatter a beam of light or a visible light as observed in activity 2.2. Okay, so solution is what? A small comparison we'll do here. Solution is a homogeneous mixture, correct? Because the size of the particles also small. Solution is homogeneous mixture, and it is a particle size is very small. But in a colloid solution, they are having a small particles, but we are not calling a homogeneous, instead of we are calling a heterogeneous mixture. And the particles are small, but it is a big enough to scatter the beam of light. But the particles are small in the case of colloid, but they are enough big to scatter the beam of light. This is the difference between main solution and colloid. Colloid is what? A heterogeneous mixture, but same thing is there, both are having a smaller in size, but in a colloid they are small, but they can scatter the beam of light. But in a solution they are homogeneous mixture, they are small in size, then they do not scatter the beam of light. And common is what? The solution is also cannot seen with our naked eyes. Colloidal also is not seen with our naked eyes. Okay, another very important definition will comes here. Scattering of beam of light is called as a Tyndall effect. So the name of the scientist who discovered this effect. Okay, for 1 marks definition they will ask what is a Tyndall effect. Means we can read the scattering beam of light, means the light is a scattering. The light is a scattering. This phenomena is called as what? Tyndall effect. What is a Tyndall effect? They will ask scattering beam of light is called as what? Tyndall effect. The Tyndall effect is named after discovery of this discovery of this method or effect by what scientist name called as a Tyndall. So due to this only is honoring his discoveries, the name itself called as a Tyndall effect. The Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. Okay, we are observing this activity several times in our home only. So in our home at the early morning, in a small window or a small hole in a room, that light is entering through it. So that is also called as what? Scattering beam of light. It is a good example of what? Scattering beam of light. This happens due to the scattering of light by the particles of dust and smoke in the air. Okay, when we are observe, when the light is coming from the window, so early morning you will see small tiny particles in that and white color and dust particles present in it. So due to these tiny particles, dust, smog, they will scatter the beam of light. So this is the simple example. Okay, this torch, when light is passes, so it will be scattered and the path of the light will be visible. So we can easily see the path of the light. This is the simple experiment. Okay, solution of copper sulfate does not show Tyndall effect here. So here this is what a copper sulfate solution we can see in this figure. So when light is passing from the torch in the first A solution, the light will not visible because the particles are very small in size, they do not scatter the beam of light. But in the second case, when light is passing, we are observing light is passing, or we can see the path of the light because the particles are enough big to scatter the beam of light. So why we are seeing objects, or why we are seeing the path of light, means the light is scattered by the some particles present in the atmosphere or present in any kind of solutions. Remember that whenever we can observe the scattering of light, means that is due to the scattering of light due to the tiny particles or particles. So remember, there is no particles means we cannot see the object, so there is no scattering of light will occurs. Due to the particles, the light will be scattering. Tyndall effect can be observed when sunlight passes through the canopy of dense forest. Here dense means what? More trees are close to each other, that is called as what? Dense populated. We can use in social very commonly, dense populated, dense area. So means what? There is a more number of people, that called as a dense populated. Like this only, dense forest means more number of trees are placed beside of each other, so that is called as a dense forest. In this forest, mist contain tiny droplets of water which act as a particles of a colloid dispersed in air. Okay, so this is a good example, right? So this is called as a dense forest. In that forest, in the forest, light is coming, correct? Light is coming from the path of like this. Okay, because of the moisture that contains small water droplet, that water droplet act as a water particles and the light will be scattering. We can observe this in our home also. We can observe like this same phenomena from the window, correct? So this is a good example of what? Scattering of beam of light. Please subscribe my channel and share with your friends. Thank you for watching.